Hello friends, a very good afternoon to all of you and a warm welcome on the YouTube channel of BYJU'S Exam Prep. I am Gourav Gupta and I welcome once again to all the aspirants for CAT 2023 as well as other management entrance examinations on this YouTube channel of BYJU'S Exam Prep, where we are basically covering all the basic concepts which are related to the quantitative aptitude that will be required to all of you for the upcoming examinations like CAT and definitely other examinations. Now, lately, in this series of sessions, we are looking at the basics of number systems. And in the previous lectures that I have taken, we have covered the classification of numbers, the concepts of LCM and HCF. And today we are going to look at the concept of factors and multiples. Now, primarily, we'll be focusing on the factors, the properties of factors, and different formulas which are related to finding the number of factors as well as the other things. So friends, a very good afternoon to all of you. Sai, good afternoon. Hello everyone. So can you all please quickly confirm just by writing yes if I am clearly audible and visible to all of you? I believe everything is good as far as the audio and video is concerned. I just need a small confirmation from every one of you, and all the students who are already present in this live session. Welcome all of you. A very good afternoon to all of you. All right, so I believe we are good to continue. We are good to start with this session. So I'll quickly put forward the agenda of this session in front of you. So we'll start with the formulas which are related to factors. So first of all, I'll tell you what are the factors of a number. We'll be talking about the different properties related to the factors of a number. Then we'll come to the different formulas which are required to find out the number of factors as well as the other formulas related to the factors. All right. And then we'll solve some of the related questions. Now, the level of difficulty of these questions, don't think that I'll be reaching to the level of difficulty of CAT, because in this session, we are just covering the basics of number systems. All right. So this session will be very important to all of you, especially for those students who are preparing for CAT, Narsi Munji, Symbiosis, or XLRI ZAT examination. And these sessions will definitely build up your basics. These sessions will be the foundation stones for the preparation of these examinations. All right. So let's start with this. So first of all, let us understand what are factors. So I'll take an example. I'll take a number and we'll try to write all the factors of a number. So let's take a number 20. All right. Now, the factors of 20 will be all those numbers which will be less than or equal to 20 and will completely divide 20. So ऐसे numbers जो 20 को completely divide कर देते हैं. तो अगर मैं चाहता हूं, like if I want any number to completely divide 20, then obviously that number has to be less than or equal to 20. A number which is greater than 20 will not be able to divide 20 completely. All right. So the factors of a number are all those numbers which can completely divide a number. Yes, Yash, for MHCT examination, definitely this session will be helpful. All right. Okay. So if I write all the factors of 20, which all of you can also do, you can also help me in writing the factors of 20. So the factors of any number always starts from 1. So 1 is the factor of every number, right? So I'll start from 1, then 2, 4, 5, 10, and 20. So the number itself will also be the factor of the number. All right. So I can see that for 20, I have written all the factors, and the number of factors of 20, as we can see on the screen, is 6. Now, every number will have 1 as the factor, and every number will be the factor of itself as well. These are the two important things that you must know. Also, if I talk about the number of factors of any random number, So the number of factors will be a finite quantity. It will not be an infinite quantity. So there will be finite number of factors for every number, right? Okay, so now 20, I can see that there are 6 factors of 20. Now, similarly, if I look at any other number, let's say 30. So I want to write all the factors of 30. I can start from 1, then 2, 3. I'll write all the numbers that will completely divide 30. 4 will not divide 30, then 5, 6, 7 will not divide, 8 will not divide, 9 will not divide, 10 will divide 30, then 15, and finally the number itself will be the factor. All right, so the number of factors of 30 I can see is 1, 2, 3, 4, 5, 6, 7, 8. So the number of factors in this case is 8, and the number of factors in this case, so in the case of 20, was 6. I would like to take another example, 36. Now 36, writing all the factors of 36, 1, 2, 3, 4, 6, then 9, then 12, 18, and 36. Now, counting the number of factors of 36, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 36 has 9 factors, right? Okay. Now let's understand some of the properties related to the number of factors of any number. So if I look at some of the properties, then I would like to go back on these numbers 20, 30, and 36. So first thing that we have already noticed that every number will have a finite number of factors. One will be the factor of every number. The number itself will be the factor of the number. All right. So these are some basic properties related to the factors. But now let us have a look at some very important properties which are related to the factors or the number of factors of any number. Now, I'll start from the first number that I've taken, 20. Now, if you look at all the factors of this number, okay, so 1, the first factor, and the last factor, multiply these two numbers. Okay, so the product of the smallest and the largest factor of the number will be the number itself. So 1 into 20 is equal to 20. Then 2 multiplied by 10 is also equal to 20. Then 4 multiplied 5 is also equal to 20. Now this will happen every time for every number. So you can always say that the product of the factors which are equidistant from both the ends will result in the number itself. So the product of first and last factor, the product of second and second last, third and third last, it will always result in the number. The same thing will happen with 30. As you can see, 1 into 30 is 30, then 2 into 15, 3 into 10, 5 into 6. Now for these two numbers 20 and 30, I can see that this is true. Definitely this is true. So this particular property will also help you in writing all the factors of any number. So let's say you are unable to determine or write all the factors. Let's say I'll pick up a number randomly, 72. So I can write the smaller factors 1, 2, 3, 4. I can see that 72 is divisible by 1, 2, 3, 4. Now you can start writing the factors from the end. So 72 divided by 1 is 72. So the last factor of 72 will be 72. Then 72 divided by the second factor, 72 divided by 2 is 36. It will give you the second last factor. 72 divided by 3, it will give you 24, the third last factor. 72 divided by 4 will give you 18, that is the fourth last factor. So this is one of the ways in writing some of the factors of the number if you have already written some of the smaller factors. Then I can write 6. So 72 divided by 6, it is equal to 12. Then I can write 8. 72 divided by 8 is 9. Now definitely if I have already written 8 and 9, there will not be any factor between these two numbers. So likewise, you can write all the factors of a number using this property. Okay, so there will be lesser chances that you will miss on writing any of the factors, right? So again in 72, the same thing has happened. product of first and last factor, second and second last, and so on. So the number of factors here is 1, 2, 3, 4, 5, 6, and 6, 12. The number of factors is 12. Okay. Now let's make one more observation which is related to the factors of the number. So I'll pick up these three numbers 20, 30, and 72. Okay. Now the number of factors in each of the case 6, 8, and 12. The number of factors here is an even number. Okay, the number of factors here is an even number. Now, this is a very, very important property here. So, as you can see, while writing the factors, 20 can always be written as the product of two different numbers. So, I can write 20 as 1 into 20. Look at the top left of your screen. 2 into 10, 4 into 5. Okay, so I have written 20 as the product of two different numbers. Right? I cannot write 20 as the product of two same numbers because 20 is not a perfect square. Similarly, for 30, if you look at all the factors, 1 into 30, 2 into 15, 3 into 10, 5 into 6. Again, 30 is written as the product of different numbers. Right? I cannot write 30 as the product of two equal numbers. But if you'll consider 36, if you'll consider this number 36, then in some of the ways, if I look at this way, 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 36, since it is a perfect square, can also be written as the product of two equal numbers. So in between, ये जो 6 है ये अकेला रह जाएगा because 36 is a perfect square. So the earlier numbers 20, 30, and 72 were not the perfect squares. That is why the number of factors of these numbers was an even number. But since 36 is a perfect square, so for every perfect square, the number of factors will always be an odd number. So this is one very important, very useful property that you must note down. Okay. So among the properties of factors, properties of number of factors, I can say that for a perfect square, if a number is a perfect square, then the number of factors, which I denote by f, the number of factors will always be an odd number. All right. If a number is a non-perfect square, then the number of factors f will always be an even number. All right. Fine. So this is the first very important property that is related to the number of factors of any number. A perfect square will have odd number of factors. A non-perfect square will have even number of factors. I've already told you why this will happen. Okay. Now let's move ahead and look at some of the formulas for finding the number of factors and other related formulas. Okay. So the first thing, how to find out the number of factors. Now we have already seen one way in which we are writing all the factors of a number manually. हम ये चीज manually कर रहे हैं. Okay. Obviously, if the number is big, then it will be slightly difficult to write all the factors. It may happen that we may miss on writing some of the factors. Now, the agenda is to find out the number of factors of any number. So let's see a perfect way of doing this so that we'll not miss in counting any of the factor of a number. Right? I'll start with a smaller number. Let's say 20. Now, the first step here is to do the prime factorization of a number. Now, what do you understand by prime factorization? I'll write this word so that you will remember it. So, prime factorization. Now, what do we mean by prime factorization? Prime factorization of a number means that writing the number as the product of prime factors. Okay, so बचपन में किया होगा 20 को हम इस तरीके से डिवाइड करते हैं prime number से. So 20 when divided by 2 it will give you 10. Then again divided by 2 it will give you 5. Again when divided by 5 it will give you 1. So I can write 20 as 2 into 2 into 5 or 2 square into 5 raised to the power 1. So to find out the number of factors of any number, the first step is the prime factorization of that number. I'll simultaneously take one more number, let's say 30. Okay, so 30 can be written as 2 into 3 into 5, or I can say 2 raised to the power 1 into 3 raised to the power 1 into 5 raised to the power 1. I'll write one more number, 36. 36 can be written as 2 raised to the power 2 multiplied by 3 raised to the power 2. Okay, so this is the prime factorization of these numbers. Okay, number can be written in primes. Yes, okay. Uh, Sai you are asking, please do a session on unit digit. Yes, Sai. So it might be my agenda for the next session. Don't you worry about that. But before that, this session is very important, very useful. Now, what I've done is I've selected three numbers which earlier I have taken, and I've done the prime factorization of all these numbers. Now, after the prime factorization is done, now to calculate the number of factors, just look at the powers of these numbers. Okay, only focus on the powers of the prime basis. Add 1 to each of these powers. So 2 plus 1, एंड देन ये वाला जो वन है इसमें भी वन ऐड कर दो, 1 plus 1. So add 1 to each of these powers, okay, and then multiply the resulting numbers. So 2 plus 1 is 3 multiplied by 1 plus 1 is 2. So 3 multiplied by 2 is equal to 6, which will be the number of factors of 20. I'll take one more example. The next example, 30. So the number of factors. Look at each of these powers. All the powers are 1, 1 and 1. Add 1 to each of these powers. So this is standard. हमें हर बार 1 ही add करना है. Okay. So add 1 to each of these powers. So they will become 2 multiply 2 multiply 2, and that is equal to 8, which is the number of factors of 30. Similarly, for 36, the number of factors will be, so look at these powers, both the powers are 2. So 2 plus 1 is 3, multiplied by 3, that is 9. So 9 will be the number of factors of 36. If I'll go back, number of factors of 20 is 6. Yes. Number of factors of 30 is 8. And number of factors of 36 is 9. We have already calculated the same thing. Okay. Now, in one of the properties where I have told you that the number of factors of any perfect square, will always be an odd number. So you can also prove the same thing using the formula for number of factors. Okay. So if a number is a perfect square, then upon prime factorization, if a number is a perfect square, then upon prime factorization, the power of every prime number, I'll write it as P1, P2, P3. These are the prime numbers. The powers of all the prime numbers will always be an even number. हमेशा जो भी प्राइम फैक्टराइजेशन के बाद पावर्स आएंगी वो हमेशा इवन पावर्स होंगी, कभी भी ऑड पावर नहीं होगी. Okay, now to find out the number of factors, if I'll add 1 to each of these even numbers, so it will give you odd multiply odd multiply odd and so on. So once you will multiply odd numbers, then the result will definitely be an odd number, and that is why we can say that the number of factors of any perfect square will always be an odd number. Fine. So this is one very important thing, finding the number of factors. So if I will write the formula for the number of factors, okay, if I write the formula for number of factors, then first of all, you have to write the number as the product of prime factorization. The first step, prime factorization. So P1 raised to the power A multiplied by P2 raised to the power B multiplied by P3 raised to the power C, and so on, where P1, P2, P3 are prime numbers, right? So the number of factor of any number will be A plus 1 multiplied by B plus 1 multiplied by C plus 1 and so on. So whatever the powers of prime numbers are, उन सब में 1 1 1 add करना है and सबको multiply कर दो. You will get the number of factors of any number, right? Also, we have seen that number of factors can be an even number it can be an odd number, right? It can be an even number, it can be an odd number, right? Okay, so this is the first formula. Now, let's move on and look at the next formulas and the next concepts. Now, the next formula that will be required in plenty of questions is, I'm writing the statement, number of ways of writing a number. Let's say the number is n. Number of ways of writing a number n as product of two factors. Number of ways of writing a number as the product of two factors. Now, whatever is required to do this thing, to find out this thing, we have already done that. Okay, so I'll give you an example for this. So 20, I'll not write it, I'll take you back to the previous screens. So 20, for 20, I have written all the factors as you can see. Now, if I want to write 20 as the product of two factors, 1 into 20, look at the top left corner of your screen, 1 into 20, 2 into 10, and 4 into 5. Is the screen stuck? Wait. People, can you please reply in the chat box if I am clearly visible and audible to all of you? If everything is going fine. Okay, I believe everything is going fine. Okay, right. So I shall continue. So if I have seen this thing, to find out the number of ways of writing a number as the product of two prime factors. The number of ways of writing a number as the product of two prime factors. We have already done it for 20. Now 20, the number of factors I have written. Okay, 1, 2, 4, 5, 10, and 20. Now look at the top left corner of your screen. I have written 20 as the product of two factors. 1 into 20, 2 into 10, and 4 into 5. Now, every two factors will get multiplied and will result in the number. So when the number of factors of 20 was 6, then I can say that the number of ways will be 6 divided by 2, that is 3. Now, same thing will happen for 30. The number of factors was 8. So the number of ways will come out to be 8 divided by 4 because every two factors will get multiplied and will result in the number, right? Similarly, for 72, we have seen when the number of factors was 12, 12 divided by 2 will be the number of ways, right? So first thing, if the number is a non-perfect square, okay, if the number is a non-perfect square, all right, then the number of factors will be even. All right, then the number of factors will be even, and the number of ways, which I can denote by W, the number of ways will be number of factors divided by 2. All right, so the number of ways will be number of factors divided by 2, and this will happen for a non-perfect square when the number of factors will be an even number. All right, now for a number which is a perfect square, as I know that the number of factors will be an odd number, नंबर ऑफ फैक्टर्स एक ऑड नंबर होगा, ठीक है. सो इन दिस केस नंबर ऑफ वेज विल बी इक्वल टू नंबर ऑफ फैक्टर्स प्लस 1 divided by 2. For example, 36. Now for 36, the number of factors was 9. So the number of ways will be 9 plus 1, 9 plus 1 whole divided by 2, that is 5. So total number of ways of writing 36, which is a perfect square, as a product of two factors will be equal to 5. All right. I hope I am clear with this thing. Now, this totally depends on the number of factors. So that is why for a perfect square and for a non-perfect square, you will get two different type of formulas. All right. Okay. Now let's move ahead and look at the next formula. Now the next formula is number of coprimes to a number that are less than the number. Number of coprimes to a number that are less than the number. Now, what do you mean by this term coprime? Right? So let us understand first of all this term coprime. Okay, and then I tell you what actually we are finding it out. Okay, now number of coprimes to a number that are less than the number. First of all, we need to know what are coprime. So coprime term is used whenever we are comparing two numbers. Okay, whenever we are comparing more than one number. Okay, now two numbers are said to be coprime with respect to each other if they don't have any common factor except one. I'll repeat, two numbers are said to be coprime with respect to each other if they don't have any common factor except one. So one तो सबका common factor हो गई, last class में LCM HCF में बताया था मैंने. Okay, so one will be the common factor of every two numbers. So two numbers are coprime if they don't have any common factor except one. For example, I'll take some examples. 20 and 24. Now 20 and 24, they are not coprime with respect to each other because there is a common factor of 4. There is a common factor of 2. So these numbers are not coprime with respect to each other. All right. 20 and 27. If I look at these numbers, now 20 and 27, among these two numbers, we don't have any common factor. 20 and 27 में कोई भी common factor नहीं है except one. So I can say that 20 and 27 are coprime with respect to each other. All right. So this is what we are going to do. So we have to find out the number of coprimes to a number which are less than the number. For example, if I'll consider 10, okay, so we have to find out all the numbers which are coprime with respect to 10 but less than 10. So 10 से जितने भी छोटे numbers हैं उनमें से हम check करेंगे कौन कौन से numbers which are coprimes to 10. So I'll start from 1. So 1 will be coprime with every number. Then 2. So 2 and 10, we have a common factor of 2. So 2 and 10 will not be coprime. Okay. Then 3, the next number 3. So there is no common factor in 10 and 3. So the next will be 3. 4, we have a common factor of 2. 5, we have a common factor of 5. 6, we have a common factor of 2 among 6 and 10. The next number will be 7 and the next number will be 9. So 1, 3, 7 and 9. These are the four numbers which are coprime to 10 and are less than 10. Okay. Now this particular formula that I'm telling you will be very useful in case of remainders theorem. Okay, so when you will be doing remainder theorem, this formula will be very helpful because this is also called the Euler number of any number. So Euler number. So there is a remainder theorem, Euler's remainder theorem. All right. So in that, this particular Euler number will be helpful. Okay. Now this is denoted by phi of any number. So I can say that phi of 10 will represent the number of coprimes to 10 which are less than 10. So phi of 10 will be equal to 4. So there are four numbers which are less than 10 and are coprime with respect to 10. Okay. Now obviously again, if the number is big, so I cannot check each and every number. So let's look at the formula, the way of finding this value in less than 10 seconds, right? So first of all, let us spend time in understanding this formula. Okay. Now phi of any number n is equal to n bracket 1 minus 1 upon p1 into 1 minus 1 upon p2 into 1 minus 1 upon P3 and so on. Okay, where n, when expressed in the form of prime factorization, P1 raised to the power A multiplied by P2 raised to the power B multiplied by P3 raised to the power C and so on. So P1, P2, P3 are prime numbers. So first of all, again, you will have to convert, you will have to write the number in terms of prime factorization, and then you can apply this formula. So let us apply this formula for 10. So 10 can be written as 2 raised to the power 1 multiplied by 5 raised to the power 1. So I can say that phi of 10, applying or feeding the values in the above formula. So phi of 10, phi of n will be equal to n, first of all n, that is 10, bracket 1 minus 1 upon 2 into 1 minus 1 upon 5. All right, now simplify this. So 10 into 1 minus 1 upon 2 is half, and then 1 minus 1 upon 5 is 4 upon 5. Solve this and you will get the number 4. So phi of 10 is equal to 4. We have derived it using the formula. Okay, right? So all the students who are right now present in this lecture, can you calculate the value of phi of 60, phi of 60 for me quickly? Let's see how many of you are watching this lecture attentively. So phi of 60 is what I require from all of you. Okay. Meanwhile, I'll take you to the previous page where you can have a look at the formula and the way of calculating the phi of any number, Euler number of any number, or basically the number of coprimes to a number that are less than the number. So let's see how many of you can quickly give me a correct answer. So I need phi of 60. Yes, number of coprimes to 60 that are less than 60. Okay, so let me solve this. So first of all, I'll write 60 in terms of prime factorization, which will be 2 raised to the power 2 multiplied by 3 raised to the power 1 multiplied by 5 raised to the power 1. So phi of 60 can be written as number 60 bracket 1 minus 1 upon 2. Next 1 minus 1 upon 3 and then 1 minus 1 upon 5. All right. So 60 into 1 upon 2 into 2 upon 3 into 4 upon 5 will be phi of 60. Now simplify this. We'll get 4 into 2 into 2. That is 16. So 16 will be the correct answer for this one. So there will be 16 numbers which are co-prime to 60 and are less than 60. All right. Okay. So these are some important formulas which are related to finding the number of factors or writing a number as the product of two factors or finding out the Euler number of any number, which will be useful in Euler's theorem. All right. Okay. Now let's look at one or two questions related to the formulas that we have done. All right. Now, question says that a number n has a number n has uh, 10 factors. Wait, before 10, I'll give you a smaller number or any other number. So a number n has, let's say, 11 factors. All right, a number n has 11 factors. So what will be the number of factors of n square? So if a number n has 11 factors, then what will be the number of factors of n square? This is the first question. A wonderful question this is. So a number has 11 factors. Now how can I write this number n as? Now first of all, look at this 11 factors and understand how do we calculate the number of factors. The number of factors is calculated in a way where we first of all convert the number in the prime factorization form. Then we'll consider the powers and add 1 to every power. After adding 1, we'll multiply them. Okay. So can I write 11 as the product of two numbers which are greater than 1? Because 1, 1, 1 हमने add किया था. So whatever the product is obtained, that product will be the product of numbers which are greater than 1. So can you write 11 as the product of two numbers which are greater than 1, or as the product of three numbers which are greater than 1? No, we cannot do that. Okay, so we can write 11 as 11 only. Okay, so in this case, I can say that the number will be of the form p1 raised to the power 10. Okay, so the power will be 10 only, right? So to find out the number of factors, we'll add 1 to this power. So 10 plus 1 is 11, and we will get directly the factors. So let's say the number can be 2 raised to the power 10. So 2 raised per 10 अगर number है तो इसके number of factors कितने होंगे? 11, right? So I have calculated, I have written the general way in which the number n can be represented. So what will be n square? The value of n square will be p1 raised to the power 20, and hence the number of factors of this number will be 20 plus 1, that is 21. So 21 will be the number of factors of this number. All right, fine. Let's take one more question of similar type. So the question is now n has 10 factors. Okay, so again, what will be the number of factors of n square? What will be the number of factors of n square? I'll give you a few seconds to analyze this problem. So what you have to do is you have to find out all the ways in which 10 can be written as the product of two numbers or maybe three numbers or a standalone number, such that all the numbers are greater than 1, right? So this is the first important thing. So 10 can be written as 10 only. 10 can be written as 2 multiplied by 5 as the product of two numbers. 10 cannot be written as the product of three numbers. All right, great. Now, first of all, I'll consider the first case. Case number 1, when I'm writing 10 as only a single number. So here, the value of n, or the general form of n, can be p1 raised to the power 9. So n square will be p1 raised to the power 18. All right. And the number of factors of n square will be 18 plus 1. That is equal to 19. So this is one value for the number of factors of this number. Okay. If I write 10 as 2 multiply 5, so the number can be written as p1 raised to the power 1 multiplied by p2 raised to the power 4. So if the general form of the number is this, we'll add 1 to each of these powers. So 1 plus 1 is 2, 4 plus 1 is 5, and we can obtain the number of factors as 10, right? So if n is p1 raised to the power 1 and p2 raised to the power 4, so n square will be p1 square into p2 raised to the power 8. Square कर दिया मैंने number, so दोनों powers double हो गई. Okay. So in this case, the number of factors will be 2 plus 1, that is 3, multiplied by 8 plus 1, that is 9. So 3 into 9, that is 27. So there can be two possibilities of the number of factors of n square. So it can be 19 or it can be 27 as well, right? एक और क्वेश्चन देखते हैं इसी टाइप का, where there can be more than one possibilities. So now you are given that n has 12 factors. Okay, so what will be the number of factors of n square? So those who are already there in this session, those who are attending this session live, please do reply to whatever we are doing right now. So what can be the different possibilities of writing 12 as the product of numbers which are greater than 1? So the first case, I'll write 12 as standalone 12. Okay, I'll do it very slowly. Meanwhile, all of you can take a lead and try to finish this question. So in this case, the number can be written as P1 raised to the power 11. N square will be P1 raised to the power 22, and the number of factors will be 23. Okay, this is the first case. The second case, I'll write 12 as the product of two numbers which are greater than 1. So I'll write it as 2 multiply 6. So here general form in which n can be written as will become P1 raised to the power 1 and P2 raised to the power 5. So n square will be P1 square into P2 raised to the power 10, and the number of factors in this case will be 3 multiply 11, that is 33. So 33 can also be the number of factors, right? Next, is there any other way of writing 12 as the product of two numbers? Yes, I have. So 3 multiplied by 4. Okay. So the value of n, the general form in which n can be written, will become P1 raised to the power 2 corresponding to 3, and then P2 raised to the power 3. Writing n square, P1 raised to the power 4 into P2 raised to the power 6. So the number of factors will be 5 multiplied by 7, that is 35. Okay, so number of factors will be 35 for this one, right? Now let's look at another way. So right now we have seen three ways. Now is there any other way in which 12 can be written as the product of two numbers? No, there is no other way. Now I'll check, is there a way in which 12 can be written as the product of three numbers? So yes, we do have 2 multiply 2 multiply 3. All right. So 2 into 2 into 3 is also equal to 12. And here the general form in which n can be written will become P1 raised to the power 1, P2 raised to the power 1, and P3 raised to the power 2. So 2 into 2 into 3, ये वे था. 1 subtract kiya, this will become the powers of these prime numbers. I'm going in the reverse direction. So from here, from here you can now write n square. So n square will become P1 square, P2 square, and P3 raised to the power 4. So here the number of factors will become 3 multiplied by 3 multiplied by 5. All right, and this is 45. So there can be four possibilities. Now let's check any other way. So is there any other way in which 12 can be written as the product of three numbers? No. The product of four numbers? No, again, there is no other way. So there can be four different possibilities for the number of factors of n square. All right. So this is the type of things. These are some of the properties of number of factors of any number, which will be useful at the time of solving these type of questions. All right. So we'll stop here for the day. That is all from my side related to the number of factors of any number or the properties of the factors of any number. I hope you like this session. If you have, then please do press the like button, and you can also tell me in case you want me to conduct any session in future. Like Sai Shri has mentioned that she wants a session on finding the units digit of a number. So definitely I'll take care of that and will conduct such a session in the future. Now, some important piece of information for all of you. New batches are available for CAT 2023. So the complete details of comprehensive program are given on your screen, and you can enroll in any of these new batches by calling at the number that is given at the bottom of your screen. All right. Also, why CAT is important, and why is it important to start for CAT as early as possible? A wonderful session that will be taken by Saral sir today at 7 p.m. So please do join us live on the YouTube channel with with a genuine reason of starting for CAT 2023 as early as possible. All right. Okay. So please do join us at 7 p.m. on 21st of January. Those who are preparing for testnet GK, the sessions have already started from 19th of February and they will continue on daily basis at 9:30. So please do subscribe the YouTube channel of BYJU'S Exam Prep and be a part of these GK sessions as well. Last lap to testnet 2023 will continue. It has started on 15th of February and it will continue up till the day of testnet. So please do join us at 8 p.m. on daily basis for last lap to testnet sessions. So that's it from my side. You can get social with us by joining any of these social media platforms. Thank you very much for being a part of this session. Have a wonderful time preparing for CAT 2023 and other examinations. We'll see you once again. Have a wonderful day. Bye bye.